Hi guys, today we're going to be talking about heat and temperature and thermal energy. So let's first talk about temperature. Temperature is the concentration of thermal energy in an object. So let's just jot that down. I don't really want to write it. Temperature is the concentration of thermal energy in an object. So in our world, we measure in temperature in Celsius and Fahrenheit, and to convert between the two real fast, this is the equation. So it's F equals 9/5 C plus 32. So I want to talk about this equation for a sec. The 32 comes from 32 degrees Fahrenheit is the freezing point of water, and in Celsius that is 0 degrees Celsius. So that's why it's the 32. And then the 9/5 just pretty much means a change in temperature of 9 degrees Fahrenheit corresponds to a change of 5 degrees Celsius. So that's how you convert between the two. And then in physics, we also use another scale. It's called the Kelvin scale. The Kelvin scale, it measures stuff in kelvins, obviously. And 1 Kelvin, and then Kelvin scale, water freezes at 273 kelvins and boils at 373 kelvins. We'll find an equation from it. We get K, the temperature in kelvins equals C plus 273. That's how we get the 273 Kelvin as the freezing point of water and 373 as the boiling point of water, since you add 273 to the boiling point and the freezing point of the water in Celsius. So what you're going to see most in your physics class is Kelvin, and that's why we use it. And now we're going to talk about how to measure heat, which is a transfer of the energy. Heat is usually measured in calories. Calories, why we use calories is that calories relate heat to changes in temperature. So it makes it more convenient for the physics problems that you're going to see, because it specifically relates heat to changes in temperature. A calorie, you might want to jot this down, is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. So that's the definition of calorie. It's the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. And what is 1 calorie? Well, 1 calorie, 1 C's, let's say, is equal to 4.919 joules. And it's also equal to this definition, which is the amount of heat it takes to raise 1 gram of water by 1 degree Celsius. That's the important part. So these are the most equations that we're going to need. And next thing we want to talk about is specific heat. So after you guys have all this down, I'm going to erase all of this. Next, we're going to talk about specific heat. Specific heat, which is C. Let's write that down. C is specific heat. It's a measure of how much heat is required to raise the temperature of a given substance. The unit for the specific heat is joules per kilogram times degrees Celsius. Sorry. Yeah, so the degrees Celsius should be in the denominator, and I'll tell you later why that is. And one of the main constants that you have to know in thermodynamics in your physics class is the specific heat of water, which is 4.19 times 10 to the third joules over kilogram times degrees Celsius. And this is also equal to 1 cal per gram per Celsius. What does this specific heat of water mean? Well, that means it takes 4.19 times 10 to the third joules to raise 1 kilogram of water by 1 degree Celsius. Well, how can we interpret specific heat? Well, high C, C stands for specific heat. What does a high specific heat mean? It means that it's difficult to heat the object. That means it's going to require more heat to heat the object. A low C, on the other hand, means it's easier to heat the object, which requires there will be less heat needed to produce a change in temperature. Well, what's the equation for relating all these things? Well, I'll tell you. The main equation is Q equals MC delta T. What do all these things stand for? Q right here stands for heat transfer to a material. M is the mass, obviously. C is a specific heat, and this is a change in temperature. Okay, let's do an example problem. Let's say that 4,190 joules are added to a 0.5 kilogram of water with the initial temperature, so Ti equal to 12 degrees Celsius. What is the temperature of the water after it's been heated? Tf. So here's the problem again. 4,190 joules of heat are added to a 0.5 kilogram of water. And the water is an initial temperature of 12 degrees Celsius. And the specific heat of water, again, which I have to tell you, is C of water, C of H2O, is equal to 4.19 times 10 to the third joule. Yeah, you're better off just memorizing the specific heat of water. I mean, there's really no way to calculate it. Degrees Celsius. So, the specific heat of water is 4.19 times 10 to the third joules over kilogram times degrees Celsius. Let's solve this problem. So you might want to pause this video real quick. So how did we solve this? Well, let me see. Using this equation. Well, the first thing I would do is solve for change in T. So change in T is equal to Q over MC. And that means I'm going to separate TF into TF minus TI, because that's the same thing as the change in temperature. And you get something like TF is equal to Q over MC plus TI. Well, using equations from the last problem, well, they gave us most of this stuff. What's the amount of heat added in standard SI units? It's just 4,190 joules. Sorry, that's a 9 right there if you can't see. Joules over, what's M? M is 1/2 kilogram. Yeah, I'm not going to include the units. It's going to require too much writing. Over 1/2. And then since the mass is in kilograms, we have to use the specific heat in kilograms as well, and with joules, which is 4.19 times 10 to the third, which is the same thing as 4190. And that's this part, and then you have to plus TI. What's TI? TI is 12. And in the end, once you plug all these values in, you'll get 14. Degree Celsius. So that's pretty much the end of this video, and let's summarize up all the points. The main points is that temperature is the concentration of thermal energy in an object. And 1 calorie, which is a way of measuring heat, is equal to 4.19 joules. And the specific heat is how how easy it is to change the temperature of an object. The high specific heat means it's very hard to change the object's temperature, meaning you're going to have to put more heat in. And the low one means you have to put less, because it's easier to. So that's pretty much the end of this video. So please tune in for the next one, and thank you guys for watching.